Hello everybody, in this video we are solving this AAHL paper of May 2021, time zone 2. Let's look at all the questions one by one. We will start with the first question. Now, easy question, section A, right? Consider two consecutive positive integers, one is n, another is n plus 1. Show that the difference of their squares is equal to sum of two integers. Now, see this, difference of their squares, okay? So you have to find the difference, right? So let's take the bigger number, n plus 1 the whole square minus n square. That's the difference. And then if I just expand this out, it will be n square plus 2n plus 1 and this minus n square. Now this n square will cancel out. So you got 2n plus 1, and 2n plus 1 simply is n plus 1. So n is one of the number and second number is n plus 1. So the difference is what we started off with over here. And finally we got that as a sum of two integers, which is over here. So it is done. We got the answer for the first one. Easy question. Let's go to the second one now. Here, okay, second question we have solve the equation. Now to solve the equation, you have to find the value of x. And remember, your x has to be between 0 and 2 pi. So let's solve this one. This will be, well, it's a cos square x, it's a quadratic equation. So you can use the formula here. It is 2 cos square x will become 1 minus sine square x. That's the value of cos square x plus 5 sine x minus 4. I took 4 on the other side equal to 0. It's good to have 0 on the right hand side. Now multiply this, you will get 2 minus 2 sine square x plus 5 sine x minus 4 is equal to 0. So you got this 2 here and this minus 4. So it will become minus 2 and minus 4. And then maybe divide by minus 2. Divide by minus 2 to the whole equation. So you get sine square x minus 5 over 2 sine x plus 1 is equal to 0. Now we got a quadratic equation and this is paper 1, so you don't have a calculator. So you have to find the roots here. So for 1, you have to find the factors which will add up to minus 5 by 2. So they just have to think about this. This will be probably 1 and 1 by 2. Not really. 2 and 1 by 2. 2 times 1 by 2 will give you 1. And when you add them, 2 plus 1 by 2 is 4. But then you want minus 5 by 2. So you just have to write minus here. Well, so you got sine x, it's a quadratic equation. So sine x values are either 2 or sine x is half. So of course you discard this. So sine x can only be half. Now from this, you will have to find the value of x because you want to solve and find the value of x. Okay, so now here you have to use the concept of unit circle, which is sine x is half when x is pi by 6. So let me quickly draw a unit circle here. And one second. And for this unit circle, you have pi by 6 over here. And the sine x value is half. This is half for this angle. But this can also be half for 5 pi by 6. So even this can be half. Sin x is half for 5 pi by 6 also. So you got x as pi by 6 and 5 pi by 6. And I believe the condition was that it has to be between 0 and pi by 2. So it's between first 4 quadrants. Answer cannot be in second and fourth quadrant because that will be a negative value. So this is the final answer, right? This is the answer. This is the question number 2. Let's go to the next one now. We have an expression x plus k to the power 7. K is any real number and coefficient of the term of x to the power 5 is 63. We want to find the value of k, binomial expansion. So now x plus k to the power 7. When we expand this, the first term is x to the power 7, right? The next term will be some coefficient x to the power 6, then some coefficient x to the power 5, and on and on and on. The last value will be k to the power 7. Okay, we know that, right? And we want this term. So let me change the color a bit. So we want to find this term, right? Because x to the power 5 is 63. So we'll work with this. This will be 63 actually. Okay, so first term is k to the power 7. This is 7 choose 1 and x to the power 6 and k will be there. 7 choose 2, x to the power 5 and k square. That's the coefficient, which is 63. So 7 choose 2 is 7 factorial, 2 factorial, 7 minus 2 factorial. That's the value of 7 choose 2. It's over here. And k square is equal to 63. Now let's simplify this. 7 factorial is 7 times 6 times 5 factorial divided by 2 factorial. 7 minus 2 is 5 factorial. This will cancel out. And 2 factorial will make this 3. K square is equal to 63. Let's solve this. Now this is 7 times 3 k square is equal to 63. So k square is equal to 63 over 21. So k square is simply 21 times 3 is 63, right? So it's k square is 3. So k, you take a square root. It's a square root of 3. But now watch, when you take a square root here, it's very important that you don't miss the point here. This is either plus or minus. And if you see here, it says values of k. Find possible values of k. And k can be either plus root 3 or k can be negative root 3. And that's the answer. Note this point. If you forget the minus root 3, you lose 1 mark there for the answer. Anyways, that's question number 3. Going to the next question. Let's look at question number 4. Okay, so now, okay, let me reduce the size a bit. Consider the function f. Okay, let's see what the question is. F of x is given to you here. This is your function f. Okay, we have it here. X, the domain can only be 4 or more. Okay, the following diagram shows the part of graph of f which crosses x-axis at a point A. This point A here, with coordinates a comma 0, and the line L is a tangent to the graph of f at point B. Okay, so L is the tangent to the curve. Find the exact value of A. This should be very, very simple. This point A is when x is A and y is 0. So at A, at point A, y is equal to 0. So that gives you, you can make this as 0. So you have ln of x square minus 16 is equal to 0. Get some more space here. So I'll solve that A here. Ln of x square minus 16 is equal to 0. So we know that ln of 1 is 0. Ln or log of 1 is always 0. So you know that x square minus 16 has to be 1. And then if you simplify this, x square is equal to 17, and therefore x is equal to square root of 17. And this time you will take only positive value and not a negative value, because this is the positive side. A's coordinate is A's x coordinate is going to be positive. So now that says A is equal to plus root 17. That's the answer. We got that for A. Now let's solve the question number B, question part B. Given that the gradient of line is 1 over 3, find the x coordinate of B. Okay, let me solve B here. For B, the gradient of line L is 1 over 3 at point B, right? So now you will have to differentiate this, right? So differentiate, you get f prime of x, the derivative of f of x, is 1 over x square minus 16, and then you'll apply chain rule. So you'll get 2x and then 0. 0 is the derivative of a constant, right? So you get f prime of x is equal to, this is 2x over x square minus 16, and we know that at B the tangent has slope, the gradient is 1 over 3. So you know this is 1 over 3. Now you just have to simply solve this. So cross multiply here. So you get 6x is equal to 3 times 2, 6x, x square minus 16 and then you get this as x square minus 6x minus 16 is equal to 0. So you have a tangent. Tangent is intersecting only at one point. So I think let me just see if there is any mistake here. Yeah, it's all good. So we just have to solve this differential, the quadratic equation here, and find the roots for x. Okay, for negative 16, the factors are going to be negative 8 times 2, right? So from this we know that x could be either 8 or negative 2. Okay, and this clearly is on positive side, so this is 8 for sure. Given the gradient, find the x coordinate of b. X coordinate of b, the answer is 8. 8 is the answer. This is how it is done. Okay, now let's go to the next question. Question number 5. Okay, a question on vectors. Let's see how we can do that. We have two vectors a and b. We have to show that this is equal to this. So it's a prove that a question. Show that, right? So let's start with left hand side, and left hand side is absolute value of a cross b the whole square. You just have to apply the formula here. Look, we want to start from here, and we should get this as the answer, and we can see a dot product here. So we'll see what we can do. So this will be a b sine theta, right, the whole square. And now you have the absolute value here. So it is absolute value of a, absolute value of b square, and absolute value of sine theta square. And you don't need ignore the absolute value for sine theta, sine square theta. So sine square theta is nothing but 1 minus cos square theta. So it is absolute value of a square, absolute value of b square. This is 1 minus cos square theta. And then, well, sine square theta is written as 1 minus cos square theta. I'm trying to get the cos theta because that way I'll probably end up with the dot product, right? Because that's how the formula of dot product is. So you got a square, b magnitude square, magnitude a square, magnitude of b square, cos square theta. I simply multiplied this to this bracket. So I get absolute value of a square, absolute value of b square, minus, and I can simply write this as, you know, the bracket square, right? So it is a dot b the whole square, because absolute value of a, magnitude of a, magnitude of b, and cos theta is nothing but the dot product, and that is exactly what right hand side is, and you say hence proved. So we have derived this. All good. Okay, so let's go to the next question. This is question number 6. We have a following diagram, shows triangle ABC. We have all the values. AB is 10, AC is 2x, this is x, and we know cos C, so we know this angle, and cos C is 3/4. Then find the area of triangle. Okay, you have to find the area of triangle and get the answer in this particular form. So first, using this cosine rule. Okay, let's use cosine rule first. By cosine rule, we can say this side, we have this angle, right? So we have 10 square is equal to sum of square of these two sides. So it is 2x square plus x square plus 2 times x times 2x cos C, right? So it is 100 is equal to, this is 4x square plus x square plus this becomes 2 times x times 2x is 4x square again, and you know the cos C value is 3/4. So 3/4, this 4 will cancel out, and you get 100 is equal to 4x square plus x square, 5x square. This is, I think, 6x square. Let's just verify the answer. Oh, no, so I made a mistake here. There is a minus sign, of course, over here. Sorry. So this is negative, right? So there is a minus sign here. So 5x minus x. So this will become 2x square. See, 4x square plus x square and 2 times 3 by 4. 4 cancels out. Oh, there is 3 here. So this is 5 minus 3, 2x square. Anyway, so you get from here, you get x square is equal to 50. And you get x is equal to square root of 50. And it's positive number only because x is the distance or the length of the sides. Okay, so we just found the value of x. This is root 50 and this is 2 root 50. Now next we want to find the area of triangle. So for area of triangle ABC, the triangle here is half, you have this angle, right? So half times 2x this side times x this side and that angle, and sine C. Okay, so now from here we know all the values, right? So it is 1 by 2, the x value is root 50, 2 root 50, root 50, and you can also find sine C because you already know cos C is 3 by 4. So we know you can use the formula here. The formula is sine square theta plus cos square theta equal to 1, and that gives you sine theta is equal to root of 1 minus cos square theta. So it is root of 1 minus 9 by 16, right? So you get 2 cancels out, root 50 is 50, and this is square root of 16 minus 9. So 16 minus 9, 16 minus 10 would have been 6, root 7, right? Root 7 over 16. So you get this as 50 root 7 by 4. And you can simplify this and you can say 25 root 7 by 2. Just divide by 2 here. And then exactly how they want the answer to look like. So it is P here is 25 and Q is 7. And that's the answer. I hope you understood this. Easy question, just simple calculations. Now move on to the next type of question here. Question number 7 says that you have a cubic equation. That means this will have 3 roots. One root is alpha, other is beta, and the third root is alpha plus beta. We know the value of alpha times beta. You have to find the value of k, right? There's only one value of k. We'll see. K is greater than 0. All this is given to us. So now you have to use the formula of sum and product of roots. So the formula for sum of roots is here, and the product of root is here. Okay, so the sum alpha plus beta plus alpha plus beta is when you add all the 3 roots here, and then that sum is minus n minus 1 and an. So an minus 1 is minus of minus k, this will become plus k, and an is just 1, right? So you get alpha plus beta, which is 2 alpha plus 2 beta. Okay, 2 alpha plus 2 beta is k. So alpha plus beta is equal to k by 2. It's a good information there. Now how about the product? So if I do alpha times beta times alpha plus beta is equal to, when I find the product of the 3 roots, that is negative 1 to the power n. N is the index, so it's 3, and a naught is 3k. A naught is this value here. It's 3k divided by an. An you will take this value, which is 1. And good, we have the value of alpha times beta, right? Alpha times beta value is here. So that is negative k square over 4 and times alpha plus beta, that is equal to, move this a little bit, this is negative 3k because minus 1 cube is negative 3k, and this minus will also cancel out. And for alpha plus beta also we have a value as k by 2. Okay, let's plug that in. So you get k square by 4, and this alpha plus beta thing is k over 2. This is 3k. The minus sign also cancelled out That's the minus sign on the both sides. So you get k cube is equal to 4 times 2, 8 times 3, 24k. And then you can also cancel out k. So this will become square. This will cancel out. You know k is not 0. Because I think it's given in the problem that k is greater than 0. So you can simply cancel out k. You get k square equal to 24. So k is equal to root 24. Now don't call it plus or minus, it's just plus root 24. Because the condition here says k is greater than 0, can't be negative. And find the value of k, done. That's question number 7. Now, 8th question we have is a question of vectors. Let's see how we can do that. There are two lines here. And they have their vector equations given to us. You have to show that the line 1, line 2 do not intersect. So they could be parallel lines like this, or in 3D they could be skewed lines, right? And still not intersecting each other. It's like pass through one over the other. Yeah. But anyways, look at the equations. I think you will see here that if you see the direction vector of L2 and L1, it is just a multiple of each other. That means these lines are definitely parallel. Okay, so if the lines are parallel, they can intersect if they are just the same lines, or they will never intersect. Anyways, we have to prove that the line 1 and line 2 does not intersect. So now the way I do it is, let's say you have a let P X Y Z be the point of intersection of line L1 and L2. Let's assume that. This is x. Okay, let me write it down here. X is 3 plus 2 lambda, and the x here is 2 plus mu, right? And they got to be equal, because that's when the point will have an intersection, the point common to both the lines. So I will equate 3 plus 2 lambda with 2 plus mu. And let's say for y, it has to be 2 minus 2 lambda, which has to be equal to this y, which is 0 minus mu. So it is 2 minus 2 lambda has to be equal to 0 minus mu. Right. You can simply solve these two equations and find out mu and lambda, but now I want you to just see that if I try to solve them simultaneously, let's say if I add these two equations, so it is 5, 3 plus 2, and then this is just 0, and 2 plus 0, when you add them, it's 2, and mu and negative mu will cancel out. So you get 5 is equal to 2. That's absurd, right? So if you get condition like this, that definitely means that there is no point which will satisfy both the lines, and there is no point of intersection. That's the point of intersection. Anyways, now next what we want to do is we want to find the distance between, just say that this is absurd, no common point. Let's complete the first one, between L1 and L2. So therefore they do not intersect. Okay, you get the point, right? The next what we want to do is we want to find the minimum distance between line L1 and L2. Okay, now let's see how we can do that. Let's say I have two lines here. We clearly know they're parallel. Let me just draw them. Let me do this in a different color. Let's say I have L1 and L2, right? We know that 204 is definitely a point here. 204. That's the point on line L2, because I've taken it from L2's equation. This is the point on the line. This is the direction of the line L2. Let me draw the direction here, which is 1, negative 1, and 1. Okay. Now, let's say there is a point which is in such a way that this is the distance D. We want to find the minimum distance. The minimum distance is always the perpendicular distance. So it's perpendicular here, it's perpendicular here. Some point, we definitely don't know the coordinates of this point on line 1. We've assumed that it's the right a point which is like, which has this perpendicular here. Okay, so now I don't know the points of coordinates of this point, but I do know their equations, right? Now I know that x, y, z values of this point has to satisfy equation of L1, which is here. This is 3 plus 2 lambda, and y value is 2 minus 2 lambda, and z value is minus 1 plus 2 lambda. Right? That's going to be the other point. And now what I want to do is I just want to find this distance here. So to do that, okay, let me clear some space here so I can solve the remaining work. I can do the remaining work here. Okay, so now the D, let's find this vector, like the D vector, right? So it is 3 plus 2 lambda, 2 minus 2 lambda, and minus 1 plus 2 lambda, and all this minus 2, 0, 4. Okay, so now I get the D bar, the vector here, 3 minus 2, this is 1 plus 2 lambda. 3 minus 2 is 1, 1 plus 2 lambda. 2 minus 0, this is 2 minus 2 lambda. And this is minus 1 minus 4, which is minus 5 plus 2 lambda. That's your vector D. Now, after you find vector D, for sure you know one condition, that this D, watch, this D, this vector, and this vector are perpendicular to each other, aren't they? So you know that the dot product is going to be 0. So I will do that here. So if I do the dot product, I will dot this with 1, negative 1, and 1. And then this dot product has to be 0. Okay, so 1 times this, 1 plus 2 lambda, minus 1 times this, minus 2 plus 2 lambda, and 1 times this is minus 5 plus 2 lambda, got to be equal to 0. So you got 2 lambda, 2 lambda, 2 lambda, 6 lambda, and you got 1 minus 2 minus 1 minus 1, and minus 5 is minus 6. So it's minus 6 is equal to 0. So 6 lambda equal to 6, lambda is equal to 1. So now as soon as you find lambda is equal to 1, you can just like plug that value in here. So from here, you get this point, right? The point is 3 plus 2 is 5. Lambda is 1. So 2 minus 2 is 0. And minus 1 and 2. It's a lot of solving. Minus 1 plus 2 is 1. So 5, 0, 1 are the coordinates of this point, and we already know this is 2, 0, 4. Now if you want to find this distance D, you can use the distance formula here. 5 minus 2, distance formula, right? 5 minus 2 is just 3 square. 0 minus 0 is 0 square. And 1 minus 4, negative 3 square, which is just 3 square. 3 square is 9, and 3 square is also 9. So you get this as right here, root 18. Right? So 6 3s are 18. You can like leave it here, and that is the answer. Let me just verify if that's correct. Yeah, mark scheme says, yeah, you can write it as 3 root 2, right? So all right, so that's how you can find the distance between the two, and I think B part is also done. It's all good. Let's go to the next question then, shall we? Ninth question here. Oh, ninth question is integration, and as IB will always tell you that use substitution, u is equal to sine x, and solve this integration. Okay, so I like to call my integration as I, which is integration of sine x, this is cos x dx, over well, we have sine square x minus sine x minus 2. Now in this case, do the substitution, u is equal to sine x, right? So and we'll just like map this entire integral in terms of u now. So this sine x becomes just u, right? Now here you differentiate, so you get du over dx, the derivative of u, and derivative of sine x is cos x, and you can simply multiply dx on the other side. So you multiply dx here. You see cos x dx is du. So now this term is du, this one. Okay, and denominator you will have u square for sine square minus u minus 2. Fairly simple. Now we again have to find the factors here for the denominator. It's a quadratic equation. So minus 2, you want it to be minus. So it is minus 2 times 1 is minus 2 plus 1. Yeah, so that's the root. Those are the roots. So you get integration I is equal to u over, the factors in denominator are u minus 2 and u minus 2, yeah, u minus 2 u plus 1 du, right? And when you get a product of roots like that in the denominator, it is always partial fraction expansion. So let us do the partial fraction expansion real quick. Let me do it somewhere here. Okay, so you got u over u plus 1 u minus 2. It is this thing here, right? That's not good. Second, let me just like, that's what I got here. This is a over u plus 1 plus b over u minus 2. Now you can just solve this. You get this as a times u minus 2 plus b times, just cross multiplying, right? U plus 1 over u plus 1 times u minus 2. And that is anyways equal to u plus 1, u minus 2, right? And here, you know that these two things are equal. And the denominator is the same. So you know the numerator, this u, and this numerator, they must match, right? So therefore, u is equal to a times u minus 2 plus b times u plus 1. And now you can just like plug in some value, say add u is equal to 2. What if you put u is equal to 2? What happens? This is 2, this is a, this is 2 times 2 minus 2 is 0, and this is b, 2 plus 1 is 3. So you get 3b is equal to 2, b is equal to 2 by 3. So you got b is equal to 2 by 3. Now similarly, you can just like plug in u as negative 1, right? So negative 1 plus 1 will become 0. U is equal to negative 1 in this expression here, right? So you get negative 1 is equal to a times negative 3. Negative 1, negative 2 is negative 3. And this is b times 0. So you get a is equal to 1 over 3. There you go, 1 over 3, right? So we got the value of this simplified like this, and now all we have to do is just write it down. So you have I is equal to integration of, don't split it into 2 as on now, it is just 1 over 3, and don't switch the factors. If people do that a lot, don't make those mistakes. It's 1 over 3 for the denominator u plus 1, and this is, it's negative 1 over 3, is it? No, it just cancels out. Okay, just verify that real quick. Yeah, and then you have 2 over 3 over u minus 2 du. Okay, now just, well, 1 over 3 is just a constant, right? So if you integrate this, it will be 1 over 3 ln absolute value of u plus 1 minus 2 over 3 ln absolute value of u minus 2 and the constant of integration c. Then once you get the this integration is solved, we already got the constant of integration and the integral value I. But now we have the answer in terms of u. So we have to replace it back and write it in the form of x. So let's replace u by sine x. All right, I is equal to 1 over 3 ln of sine x plus 1 minus 2 by 3 ln of sine x minus 2 plus c. You can leave it at that. That's the answer for this question number 9. Okay, moving on. Section B. I think we'll do section B in a separate video. So see you in the next video for section B problems of this paper. Bye for now.